So guys, thank you again for the invitation. I think we brought the Xtremity concept and the Xtremity socket for the first time to Australia in AOPA last year in October. I would call it like a soft launch for the first time, just to show the concept and how it would work. And this is the first official webinar. And among all the different products that we do manufacture at WillowWood, Xtremity is quite unique because it's the only one that refers to a socket concept. It's not a liner, not a traditional alpha liner. It's not a foot, not a traditional meta foot, but the socket is something that speaks to our heart and souls as prosthetists. And it's always interesting to introduce alternatives, different ways of getting that done. So on the next minutes, I will try to share with you a very simple concept, and hopefully you guys can understand and enjoy it and imagine if this is something you can use on your practice with any benefit or not. So we are a small group. I just want to keep this interactive. If at any point anybody wants to make a question, please unmute yourselves and let me know, or at the end we can always talk about it. So a little bit of context, Xtremity was acquired by WillowWood recently, and this is again a transtibial socket system that we have incorporated to our portfolio, and it could be done either using a central fab, our central fab system, similar to what you can use at the Mason central fab, or you can buy the kit and do it yourself. And my goal today is just to share to you in more details, but on a large scope, how it is done and how easy the system is manufactured. Okay. So let me try to move to the next slide. So guys, from today's presentation, if you could remember just two words, those are these two words here that I have highlighted. This is an adjustable definitive socket system. What do I mean by adjustable and definitive? At the same time, it has carbon fiber enough on it that can be considered a definitive socket. It has enough strength on it that can be defined as a definitive socket. It also has enough polymer on the mix that allows us as prosthetists to continuously adjust this socket. And so these are the two main concepts that I would like you guys to remember after this presentation. So the way we describe it, it's a carbon infused polymer socket. If you look at it from the outside, you have clearly this carbon look. If you look at it from the inside, you can really identify the polymer aspect of it. So this perfect combination between carbon and polymer is what makes this Xtremity system an adjustable definitive socket. So on the next slides, I'll try to explain how it is different from the other system available and why you should pick one over the other and when. So the biggest difference or the biggest focus here, I would split the prosthetists in two big groups. Those prosthetists that are looking for a very quick system that I can cast directly over the patient's limb and try to make my socket automatically out of my casting. And if that is the case, this is not your most favorable solution. I would recommend you to go from other available systems. And just in the top of my head, I can think about the Amparo system, the direct socket from Osers. Those are systems that you cast directly over the patient's limb. And once the cast is over, that is your socket and you are done with the benefits of it, but also with the limitations of it, because it's very hard to adjust or to create your own shape. The Xtremity is exactly for the other part of this group. It's for those prosthetists who are very proud of their shapes, their positive casts, their brims, and the way that they create the flares of their sockets, and they don't want to give up on that artistic part and then control design of their socket. Those are the guys that should be using or targeting the Xtremity, because the Xtremity will be performed over your positive mold. It will be aiming to replace with benefits the lamination process of the fabrication, but always considering you still creating your positive mold, with your flares, with your transition lines, with the shapes and reductions that you want, and not with what comes out of the casting process directly. Okay? It still keeps it simple, very efficient, very functional, but respecting your skills as a prosthetist to create the shapes that you like on your patient. So basically, out of this system, there will be two different products that will come out of it. One is a hard socket, and the other one is a flexible inner. But again, the secret is on this combination of this carbon-infused polymer combination. And I'll try to show to you in details how it works. So I always like to share this picture with you guys. This is a workshop actually in Queen Mary Hospital in UK back in 1918, more than 100 years ago. And it's a little bit scary to think that not much has changed. If you look at this picture, you still see some sockets and some benches and even like a thigh corset and with some hinges there. Every time I show this picture, the colleagues start finding each other in this picture. Oh, I'm that guy in the back with the mustache, or I'm the guy in the front. But our way of manufacturing has not changed much. And every time we talk about sockets, it's something, again, that's very dear to the prosthetist because that's where his art and his heart and soul is placed. Like an artist with his paintings, the sockets is where we can really show our knowledge and our experience. So with the Xtremity system, the phase that we are efficiently targeting is here. We want to eliminate or replace with benefits the lamination process. And I'm sure all of you identify this picture and of course feel familiar with what's being done here. So the idea is to replace all the playing with the carbon fibers and the nylon glasses, and especially with the resins and fumes and all these procedures of creating a socket through a lamination process. This will be totally replaced by the Xtremity system. So again, we all agree, we all know that our volume and shapes from our patients, the residual limb from our patients are in constantly change, constantly fluctuation, some more than others, but it's always a headache for us as prosthetists to keep this volume and this shape in place. So the adjustability feature on this Xtremity socket is very, very important. Think about, sometimes we call it as non-billable events. When you make your prosthesis for your patient, after 2 or 3 weeks, the residual limb shrinks a little bit. He returns to your office. Usually it's Friday at 3 p.m. when you're about to leave. And now you have to spend like an hour playing with pads and trying to rebuild this volume that was lost and make the patient comfortable again. The system on Xtremity is so simple that you can readjust multiple times. That makes it so much easier events like those, volumes and shape, because of the polymer part of it. Every time, sorry, let me go back here. One thing that's very important for you to understand that in every socket, in every Xtremity socket, you always have the option to choose between 3 different suspension methods. You can use the traditional pin lock system, you can use a vacuum, an elevated vacuum system, or you can use the traditional suction system with an expulsion valve and a sleeve. Those 3 systems, they're all mounted, they're built into the distal end of the socket, and you can interchange them. You can start with your patient on a pin system, and if for any reason, let's say that he's on a hybrid alpha liner with a progressive profile and using a pin connection, and for some reason he's going to evolve to a smart temp system and you want to switch to a cushion liner, you can always keep using the same socket instead of making new ones, because the same system that you can build the pin can be replaced in the socket by a system with suction or even with vacuum. I'm going to show it to you in the next slide how easy it is done. So here, I hope you can see my arrow, but here I have the socket and you can see the distal end of the socket. This is what we call the base housing. This is where all the 3 different options of suspension will be placed. And we call this part a bridge. So the bridge will have a release button if you'll be using a pin, or also we'll have a system to release the valve. So they're all interchangeable, and they all go hidden here inside the base housing. At the end of it, you're going to connect to a base plate, and the base plate will connect to any 4-hole connectors of your choice. Could be a male, a female pyramid, whatever you prefer to keep on building and connecting to the remaining parts of your prosthesis. One of the most interesting parts of this Xtremity system is what we call the base plate. The base plate, and I'll go back on my slide here, the base plate is the last part of the socket before it connects to your 4-hole system, pyramid, male or female. And it has one very interesting alignment alternative or feature for you, which is 6 millimeters of slide and 30 degrees of rotation built on it. So if you look at my pictures here, you can see how my 4-hole pyramid is placed in a very center position on the top picture. But if you look at the bottom one, you can see it's very much displaced to the left and rotated. And all these lines, these reference lines, help us to create the alignment that is needed. Please remember, you still have all the freedom to continue with alignment changes and fixtures below your 4-hole pyramid adapter. You can always put sliders or different type of adapters, but the base plate itself already offers you a lot of adjustment on it. 16 millimeters of displacement into 30 degrees of rotation. Every socket, every kit that you buy comes with the socket, with your suspension choice, and with the base plate together. It comes as a complete solution. And then you can again use all the offsets that you need after the pyramid, after the 4-hole. The fabrication is a very simple process, and I'll try to show to you here how it's done. I'll share with you a video that explains exactly the ABC. But basically, it uses one very simple pan. It's like a little oven, very simple. The only secret of this oven is that it has resistances that keeps the temperature even, both inside and outside the cone, the socket, and it has the exact size to fit the socket inside of it. But you're gonna heat the socket inside that oven for 23 minutes. The socket will be in the right temperature. As soon as you remove it, you'll be able to shape it to your positive mold that is already prepared and waiting for you. And after that, all what you have to do is to assemble the suspension of your choice on the and connect with the base plate and go for your fitting. And if needed, simply using a heat gun, you can adjust multiple times in the same spot the socket, both by pushing in or pushing out, depending on what your patient needs during their usage of the socket. Most commonly, most of the time, the adjustments will be by pushing in due to atrophy of the residual limb. But let's say that the patient has a proeminent or very sensitive distal end of the tibia or fibula head, that for some reason you want to create some sort of adjustment pushing out. You can also do that repeatedly without damaging the socket, differently than any other regularly or traditional laminated process. And I'll show you guys a video in a minute. Another nice feature of the system is how quick you get to this quality fabrication system. The whole procedure does not take more than 55 minutes. And out of this 55 minutes, half of it is actually the oven heating the material, so you don't have to do anything yourself. So it's a very efficient system in terms of speed and manufacturing, with a very high consistency at the end. So we calculate 23 minutes to heat the material. It doesn't take more than 3 to 5 minutes to shape, to pull the socket over your positive mold and let the material cool down. If you are using a plaster positive cast, it's gonna cool down in 5 minutes. If you are using a foam, a polyurethane foam on your positive, it will take no more than 15 minutes to cool down. When it's cooled down, you're gonna just create the finishing, no more than 15 minutes. And in an average of 5 minutes, you'll be assembling the distal attachments to it, and you are ready to walk the patient in less than 1 hour. So here I want to share with you the video. And all what you need is very simple tools. You need gloves, powder. You're going to have this base plate like a traditional vacuum station. You're going to measure the height so you can pull the socket all the way to its bottom. You're going to protect or cover the positive cast with your socks. And this is the little oven that I mentioned to you guys. You can see it seals completely. It sits in the middle. And as I said, there is a resistance inside and outside the socket, creating a very even temperature. This oven, it's very light, very portable, not expensive. And its only function is to heat this socket to the right temperature. So the only choices you have to do is to tell the oven, is this a hard socket or is this a flexible inner? Once you decide, automatically the oven starts to heat up to the already pre-assigned temperature. And when it comes to the right time, right temperature, the alarm goes off, reminding you it's time to do the procedure. So now you remove the socket, you put on the table. It's like a melting cheese. It's still hard enough, but you can flex the fibers. You're going to stretch it, and in one strong pull, you're going to pull over your positive cast, and you're going to pull all the way down. I make reference lines so I know what's my ML and AP. I want to make sure that those follow my alignment. And if I need, I take the base plate and I give a final push. So it goes all the way until it touches the bottom of my cast. Once that is done, I am ready now to seal the distal end. I'm going to roll over my latex sleeve over my cast, and I'm going to apply vacuum. And once I see the vacuum is working, now I can go for my first coffee in the morning because the job is done. That's it. Now I just have to wait until it cools down and go for the next procedures. So again, this is the most important video of the presentation, just to show you how easy it's done, and we can repeat at the end if any one of you guys want to see it again. The next very important part of it is the adjustability, how easy it is to adjust the sockets after it is finished. And I want to show you also a little video, but have that in mind. You can repeatedly heat and change the same area, different than our laminated sockets that most likely I will burn the fibers. It will have this burning effect, or my fingerprints or my glove prints will stay on it. With this special skin that we have on the outside of the socket, you can repeatedly heat the same area. And as I mentioned before, you can both push in or out depending on what your patient needs. So please pay attention to this video. Here I am pushing the fibular head, but right now, look at my arrow here. I am just easily pushing from inside out at the distal end of the tibia. Let's play the video again. That's how easy it is. Remember to push out or in. Most of the time we will push in. If the patient has an atrophy in the first weeks of usage, we can always push using a very fancy tool called the palm of your hand. The most common rectification that we do is in the medial and lateral flares of the tibia when the patient has a volume reduction, or a little bit push on the gastroc part from the posterior wall. Very easy, just with the regular heat gun, you hit the area and you can do it again and again. It's not going to damage the socket. Usually when I give this presentation, depending on where in the world, I try to call both the practitioner and his technician to the room, because the practitioner is the one who will buy into the concept, into the idea, and understand the benefits. But in many countries, is the technician the one who will actually manufacture and deal with the manufacturing on every day. So I need both in the room to understand the aspects of it. One of the most important benefits for the practitioner and the technician is, of course, their health, because in this system, they will not be dealing with carbon fiber and carbon fiber layers. There will not be any resin. There will be no toxin fumes. I don't know you guys, but my wife knows exactly which day I laminated carbon fiber sockets in the lab, because I go home scratching myself, and she already know, you laminated today, right? And yeah, how do you know? Well, you were scratching again. But I'm sure you all understand how annoying those carbon dust can be to our skin And if we can eliminate and bypass that process on the lamination, that's a great benefit to all of us. This is an interesting slide that I always like to keep in present here. The amount of waste that we create on our regular lamination with the leftovers from our resins, on when we are thermoforming and all the leftovers materials, it's amazing how much material we waste compared to the Xtremity system. And interesting enough, I was presenting this in Norway, and one of the customers said, guys, I need this system, even if it's more expensive. And then say, well, okay, but why? Why so? Well, in the Nordic countries, we are so green oriented. Then when I'm going to apply for a tender, a governmental tender, I get extra points if I can show them that I'm using more environment friendly technologies. And this is definitely something that I can benefit from. So I thought it was a brilliant input, and I want to share with you guys that aspect as well. I just hope that on your labs, the techs don't try to make neck collars with the leftovers of their plastic bubbles, right? So again, what we are trying to solve here is a consistency in terms of quality, in terms of time, and have a very efficient procedure that, again, will improve our efficiency over the long run. And I always revisit what we call the non-billable events. How much time do we actually spend on rectifications when there are volume changes and we have to go back and forward with pads and heating and playing with the regular sockets, and how easy, you just saw with the heating gun, how easy and how quickly it is to rectify and make those changes both in and out with the Xtremity system. It allows you to go in and serve also remote appointments. I remember together with Bill, we met one guy that works from his van. He made his van his own mobile workshop, and this is a perfect solution for that kind of situations. If your practice is involved with remote appointments and you have to be efficient and quick and get everything done. Together with the oven, you can definitely transport the oven with you because it's very light, and you can get it done anywhere you are, as long as you have your positive mode ready with you. I want to quickly touch this kind of situation. We all know that some of our patients have like a not normal distal end shape of their residual limb, a more conical solution or situation. And we have a system that allows you to create your own distal end pads. So if you have those shapes and you think that the regular socket shape would not match, you can always create your own distal end pad. And it's a very simple system where you will inject silicone from the distal end of the socket, creating the pad and filling the void between the positive mode and the regular shape of the socket. So have that in mind, that there is a simple solution for that as well. The second product of, let me pause here for a second. And Bill, I want to open for you and for all the attendees, if you want to unmute, or if anybody have a question at this point regarding the hard socket that I presented so far.
So a couple of questions relating to the base plate, if there's any tilt in the alignment base plate, and also in reference to the slide, the 16 millimeters, is that 8 millimeters in each direction?
Correct. It's 80 millimeters in each direction, and the 30 degrees of rotation is 15 in each direction. This is a small extra tool to allow you to alignments. You can always rely on the traditional offsets adapters out in the market because they're all compatible with the 4-hole system that will go at the base of the socket. But I do want to mention that if you have a very abnormal alignment or shape, this could become one of the contraindications. If you think that with all these tools that the base plate offers, plus the regular offset systems are not enough for this extreme varum or valgum residual limb, this could be one of the contraindication of this prefabricated system. And I'll cover that in a minute as well.
Sure. Now there's a question on the temperature to heat the preform 2. So what temperature does it get heated to, which is a specific temperature in the
it's a specific temperature. Yeah, in the US we work with 375 Fahrenheit. I believe that's like 135 degrees Celsius, but it's the only temperature that the oven goes. And I forgot to mention one thing, and this question helps me on that. As soon as you place the socket, the hard socket, at the oven when it's cold, as soon as you turn the oven on, it will consider that everything is cold inside, and it will take those 33 minutes to bring the temperature, always the same temperature. That is the right temperature to perform the molding. Once it reaches the temperature, the thermometer will switch to a clock, and it will count 5 minutes counterwise. And so from 5 to 4 to 3 to 2, when it reaches 0, is when the alarm goes off to tell you that you are ready to perform the pulling of the socket and creating your socket. So there's nothing that you have to choose or you have to play and mix. Once you play, you press on and you tell the oven that this is a hard socket, it will only go into one direction, which is the right temperature for the performing the socket. And of course, guys, I will make this presentation available for all the Masons team, for you, Bill, and your team. So whoever is attending the webinar today, please make sure that they have access to all these informations. And I'll be more than happy to give more details. This is like the first overview, just to explain the concept, but we have a much more detailed fabrication step-by-step for those who will be implementing this technology, okay?
Yes, of course.
Any other question at this point?
The question from Jamie, the build height of the distal end and the weight rating of the system.
So I'll show you in a minute when I go to the measurements, what are the limits. The amount of space that the suspension system uses is not much. It may seem a lot when you look at the socket, and let me go back here on a couple slides just to explain what I mean. Let me see if I can go back here. One second. I just want to show a picture of the socket here. So yeah, here I can tell you exactly how it works. If you look at this space here in my arrow, the socket does not end here at my arrow. The socket ends at the mid portion of this plastic base here. So the space that it uses is just a space enough to use our suspension methods, this bridge. So it does not use more than a regular shuttle lock space would use on your lamination socket anyway. It's like building the shuttle lock into the base of your socket. So it's not going to use extra space. It's the same amount of space that a regular shuttle lock would require when you're going to add it at the bottom of your socket. And then you have the base plate, yes, and then connects to the 4 millimeter. And in terms of length and wide, I will show you in a minute when we go to the measurement template, okay?
Sure. That's it in terms of the questions. Just a couple of comments there on the adjustability post-forming, and the heat adjustability is a bonus.
Perfect. And guys, at the end, I'm going to then open for all the remaining questions and comments after you see the whole presentation, but I think it was good to clear those initial questions at this point. Okay?
Sure.
So moving on, the second product that is part of this system is a flexible inner that is manufactured in the exactly same way, in the exactly same oven. So again, the only hardware that you need to perform Xtremity is that little oven. And here I'm making a comparison in terms of price with the other systems that I mentioned to you. The oven itself, it's so simple and so non-expensive. I'm not going to call it cheap, but it's non-expensive, that the investment that you have to do up front to have the hardware is absolutely not significant, especially when compared to those other systems that I mentioned before. So I encourage you to talk to your Masons team if you are interested in this methodology. to get an estimate of how much that little oven cost and to be creative on how to make it possible, because our idea is that the hardware should never be an impediment, an obstacle for you guys to use the technology if you really understand and see the benefits of it. So with that oven, you can create this flexible inner, and I'll show you guys in a minute how it's done. The hard socket that I explained before, it comes in 7 different sizes, and I'll show you in a minute how to choose them. This flexible inner, exactly because it's flexible, it's available in only 3 different preformed sizes, very flexible, very easy to use. And the beauty of it is that regardless how much you pull, it will never change its consistency. It will always keep the 3 millimeter thickness on the wall, and there is no seam connecting the distal cap to the other. It's like a one single piece. So we all know how hard it is to do those inner sockets by hand, and then you keep praying that the distal cap does not disconnect from the main body, and how you have to glue the cone to create the cone, and how that's a weak link there. So the consistency and the quality of the material is very good, and it's a combination of 3 different proprietary foams that allow us to do this inner flexible socket. And I'll show you guys in a video now how it's done, okay? So same procedure, same oven. Now we're going to form the oven on the keyboard. That's not a hard socket, but this time it's a flexible inner. So the temperature is a little bit lower than the hard socket, but it's the same step by step. I turn it on. I inform that it's gonna be a flexible inner. I press start, and it's gonna hit until it reaches the temperature. Switch the temperature to a clock, counts 5 minutes, and when it's ready, you remove it. You apply your powder. Now I don't have any concerns about AP and ML lines because it's just the inner flexible, and I'll push all the way in until I can feel with my hand that my positive cast, either plaster or foam, is touching my inner flexible. And then I repeat the same procedure. I just bring my latex sleeve up. I apply vacuum to the system. And now I go for my second coffee of the morning. And it's done. Sometimes it's kind of scary how easy, how simple it is, but that's all what it needs to let it perform with this kind of quality and this kind of consistency. That's it. Usually the best ideas are the simple ones. So let's talk about indications and contraindications for this transtibial system. So remember, guys, this Xtremity system, at this point in time, it's only made for transtibial patients, both unilateral or bilateral, but we don't have a transfemoral solution yet. Emphasis on the yet. The traction, the acceptance has been so high that it makes sense for us to continue to explore to bring a similar system for transfemorals in the future. But at this point, remember, it's for transtibials only. The weight limit for the patients that were tested is up to 275 pounds. You can help me here, Bill, to do the translation. 275 pounds in kilos. I'll do that in a minute.
I'll pop it in the chat. I'll pop it in the chat.
Perfect. But I believe it's 125 kilos, guys, which should be absolutely more than enough to our average patient. And the distal circumference that is accepted on those 7 sizes of the hard socket is circumferences between 26 to 38 centimeters. Please remember, if you are using a liner, that has to consider already the circumference of the liner in the top of your residual limb. Most likely, if you are casting the patient has the residual limb, they has the liner in the top of it. So that's the circumference that you consider, between 26 to 38 centimeters at the 4 centimeters at the distal end of the positive mode. And the socket length, that I think was one of the questions, it has to be no longer than 29 centimeters. So for example, if I go to the contraindications, if you have a very bulbous, a very regular shape limb that you can see that you will not be able to pull physically the socket all the way down through the positive cast, then it's definitely not an indication. If the alignment is so off in terms of varum valgum that you cannot fix it, correct it with all these features that the base plate offers and the regular offsets in the industry, that will be another reason why not to use the system. And of course, if the measurements are outside of the sizing chart, if you have a very tall basketball player that had a SIME amputation, most likely the length of his socket will be more than 29 centimeters, and it will be a contraindication as well. And of course, if I have a SIME amputation or a transfemoral or a hip dysartic, those are the type of amputations that are not contemplated by this first concept of transtibial extremity sockets. With that being said, I want to share with you one video here.
The real challenge for us was to develop a plastic that would mold very comfortably and very nicely at about 250 degrees Fahrenheit.
We've had to make dozens of iterations and approaching thousands of prototypes to zero in on a formulation that has the balance to do something that polymers just don't do.
So the most unique thing about our extremity socket is that it's injection molded. The extremity design starts really here on the computer to develop a lot of this engineering, and then you have to be able to translate that into prototype parts. From there we go to injection molding.
So we start with aluminum raw material, or steel as the case may be, and that comes in just cut to size, and then we machine it into the cavities and cores that create the geometry for the mold. The cavity is specifically shaped just exactly like the plastic part when it comes out.
Our molds have been precisely engineered to high tolerance and finish specifications so that the resulting components fit together seamlessly. Metal parts are designed for long-term durability and to withstand millions of cycles. They are individually CNC milled from aircraft-grade aluminum and stainless steel and precision tested with state-of-the-art equipment.
This is made out of plastic in a way that's very repeatable, and we can engineer into it so much more than a standard socket would have. We can make thousands of these out of our tool. They come in different sizes, so we have different tools that make them.
To make a blend that can make an engineering polymer in a structural application and yet still be formable on the body, it's a very meaningful problem, and we knew there's not a simple answer. People have been trying to find a solution for decades.
So here's the injection molded socket as it comes out to the practitioner, and here's the finished product. This took less than an hour to do, start to finish.
Mainly the explanation of the fabrication and the quality control of all the manufacturing procedure, but I think that the video explains by itself all the stages of manufacturing. I just wanted you guys to get an idea of the inside of the manufacturing plan and how high-tech equipment is involved to create that. Okay, that was my goal with that video. And here I just want to finish explaining the sizing and the mold preparation. It's a very easy step-by-step. As I mentioned before, the hard socket comes with 7 total sizes to choose from. And I want you to pay attention here on the numbers. Actually, the 7 sizes represent 4 sizes, but every time you see a little plus, means that we have an option for that size to be a conical shape. So you have actually 7 sizes altogether from 4 different circumferences measurements. This is very much aligned with the whole alpha liner system, where you also have a conical transtibial option, which is quite unique in the market. So this is the sizing chart. Very easy, very simple. I'm going to guide you guys in 3 simple steps. The first thing you're going to do is take the distal measurement at 4 centimeters at the distal end, right? Like you normally would measure for a regular liner. In this case, you can see here that my measurement is 30 centimeters. So among all the different sizes in the orange column here, I can look for the size 30, and I can see that 30 falls on the size 29, which goes from 29 to 31.9, almost 32. So I already know that the cone is going to be a size 29. What I don't know yet if it's going to be a standard or a conical. And that's why I do the second and the third measurement. The second measurement is from the MTP all the way to the distal end. In this case, it gives me a 15 centimeter. And you can see here on the right, left-hand side, I have all these numbers. I'm going to go all the way to the column when it says 15. And then I proceed with the third measurement, which is the circumference at the MPT, mid-patella tendon level. In this case, it gives me a 34. So I know it's a 29. I know it's a 15. And between the two, I will see where the 34 sits. So I see here 34 is too big for a standard. So most likely this guy is going to be a conical 29. That's how easy it is to choose between those 7 sizes. And even then, if you're not satisfied, you can always use our website and just feed those 3 measurements there, and the system alone will tell you what is the right size for that patient. I would say that's the most, I would say, learning curve. Very easy 3 steps to choose which one of the 7 sizes is the right one for your patient and your case. A few little tricks or tips from my experience. As we will be performing this pulling from the socket to your cast, sorry, you don't want to have extra material outside of your trim line. So you want to remove these extra materials and try to make a transition as smooth as possible. It can be a little bridge, but you don't want to have like 2, 3, 4 centimeters of extra material, because you want to make sure you pull all the way down and that the distal end of the cast touches the distal end of the socket. So you don't want to create any sort of obstacle, physical obstacle, during the pulling on the system. And here you can also see the 29 centimeters that I'm talking about. If this line here is more than 29, which is a lot, it will probably be a contraindication for the system. Here's another visual sample of what kind of buildups you are not looking to. You don't want these huge posterior buildups that would also prevent you from pulling the socket physically all the way down to its distal end. Finishing the socket is very, very simple. For those of you used to work with polymers, it's very similar. That's when the polymer aspect of the socket comes to play. Again, you're going to use those cones to create the smooth brim, but it's very easy, very friendly to cut and prepare those trim lines. To remove the socket, you have a few options. One of the options is just to blow air from the distal end to see if the whole socket comes out of the positive mode. That's the easiest one, because that's the one that will save your positive mode for another use if you want to. And when you are considering your trim lines, you want to keep those guidelines as a reference, but that's not the rocket science. You have the freedom to choose the shape and the socket and the trim line of your will, of your preference. Here you can see a different system to remove the socket from the cast. Maybe this is the most common one, when you just use a block to gently hit on the lateral and medial walls of the socket and slowly removing it from its cast. And if nothing works, then you would go for the breaking solution, when you just break the positive mode and then remove the socket from the cast. But on that third solution, you're going to be losing the positive mode for future references. To smooth the brim, again, you're just going to buff it at the proximal brim. Very easy, very friendly material to work with. It really doesn't create any typical sharp, hard edges like a 100% carbon laminated socket would. It's very friendly, very easy to work with it. And you always finish using a wet sand for the final touch. Questions at this point? I want to stop sharing so I can see you guys and we can all look to each other. Bill, I want to be respectful to the people's time. We have like a few minutes left. This is the first initial overview of the two products that come out of the system, the hard socket and the flexible inner. Both of them, the whole goal is to be financially very viable and competitive to regular laminated central fab laminated definitive sockets. The flexible inner is very competitive for those who still work with those flexible inners to compete with the P-Lite inner sockets or something similar. It's very competitive as well. So I just want to give it back to you, Bill, and offer the floor for any questions or comments at this point.
Sure, thank you, Gyro.
I can see the chat now that I'm not.
The flex, you can see it. Okay.
Yeah.
Yeah. So just how would you describe, I guess, the flexible inner? Is it more like a P-light or a Kesey cone or one of the
Exactly.
Other
That's a good comparison. A P-light or a Kesey, but that is made in minutes, and not only the time, but the quality. Really, the quality of the flexible inner. The fact that it has no seams and keeps always this 3 millimeter thickness regardless. For those still working with flexible inners, I would say that it's a P-light liner with steroids and very competitive because of the time that you'll be saving and the quality of it. And the two parts do not have to go together. You can use, my recommendation actually, if you are using a liner, silicone gel, an alpha liner with your patient, you don't need an extra flexible inner into it. Go directly to the hard socket. And if you are using a flexible inner, you don't need a liner, most likely. And the flexible inner does not have to go necessarily with this socket. You can use the flexible inner as your standard flexible inner with your regular laminations as well, if that's your preference, okay? The two products are not mandatory to be used together. Then I see a comment from Andrew, if there's any plans for an alignment jig for the adapter placement. This is my beef with the ISX IceCast. Yes, we are always looking into ways to improve the usage of the system, and an alignment or improving alignment options is always on our radar. We have to create some sort of priorities. Do I want to go with the system as it is and try to explore a transfemoral option, an opportunity for a transfemoral system? Or do I want to wait with the transfemoral and work on the alignment jigs? On R&D, you're always playing with priorities. I wish we could do everything at once, but I'm sure you understand we have to think about what comes first in terms of priority. But alignment is always on our radar, absolutely. I like it.
Yeah.
But I can see that you're already thinking through, because that's exactly what we are at. This is such a rich opportunity and technology that we can only move forward. Yeah, absolutely. Bill, from you or from your team, anything else? I don't see anything else on the chat right now, unless I missed anything.
There's nothing else in the chat at this point. So if there is other questions, pop them in the chat or feel free to unmute yourselves at this time. And
I just want to make sure that this is already available at Masson's. Both the ovens are already prepared for your electrical system, and the whole products and procedures are ready for you guys to start using. The whole goal of this initial presentation is just to expose and explain how the concept works. I don't think that please don't consider any of you guys certified on this product yet or ready to use, but definitely use and abuse from Masson's team with Bill and the whole education team to get your hands dirty and really try them on. And they have the oven available, and I'm sure they can facilitate a more hands-on learning experience for you guys. I think there's a commercial question for you guys here. Do you have any rough idea of cost yet?
Yes, Brendan. So we'll send out some more technical information and pricing after the webinar. But just to give you an idea, the socket kit, the Xtremity socket kit, which includes the preform and the alignment base, is a little under $1,000, $993. And then the oven, and sometimes, when we mention the word oven, many people may think, tens of thousands of dollars. So we are referring to the oven as a benchtop heating unit, and that is under $1,500. So it's quite a small investment for the benefits of the technology that Gyro's described in the presentation.
It's probably 1/3 or 1/4 of the regular cost of the hardware from the other systems. So we wanted it not to be an obstacle for those willing to use it. And Bill, once you have it in front of you, the flexible inner, do you already have a rough number about how much it's going to cost?
Yeah, the flexible inner is 184.90. So I think that compares well with the Keezy cones, and just to highlight point easier that these flexible inners can be used with your regular laminations. That's a trend we've seen here. Even prior to reducing this system, we have been using those flexible inners on a variety of our transtibial laminations here.
Yeah, and I can see Anton saying that you guys will be sending the pricing after the webinar. And I strongly encourage you, if you have a chance, to put your hands on the flexible inner and on the socket. That's the only bad part of the webinar, because you cannot touch, you cannot feel it. But I know that the Masson's team have it handy, and we'll be happy to share, because it's really part of the experience to see the quality and the outcome, both of this adjustable definitive socket, but also of the flexible inner. Bill, it's 5:59 p.m. my time, or almost 10 a.m. your time. I really want to be respectful to anybody's time here. I want to offer myself to be available for any remaining questions or comments that may come up after the webinar. You guys have my contact, of course, and I really appreciate the time and the opportunity to speak to you today. And for those who couldn't attend but want to see it on the recorded webinar, it's going to be available to you guys. So I really appreciate it. Thank you very, very much.
Yes, thanks, Jaro, for the presentation. And yeah, please reach out to the Masson's team with any further questions on the Xtremity socket. Thank you.
Thanks, Andrew, Brandon, Jamie, for the comments as well. Appreciate it.